Hello all. Here is the KEB Electronics DC motor speed control, model KBCC-225R. That's a very simple drive to hook up and run. This drive is reversible. Sometimes you'll get these KB Electronics drives and they only run in one direction. But this has a reversing board on it. This contactor right here switches the output from forward to reverse. Now I've got a variac connected to L1 and L2. The variac's output is set to 220 volts AC. This is a 220 volt AC single phase drive. I have two series 100 volt 100 watt light bulbs connected to A1 and A2. That's the armature connections to the motor. I've got these two light bulbs simulating that DC motor. I also have this oscilloscope connected to A1 and A2 so that we can look at the waveforms of A1 and A2. Here's a potentiometer, and this is a 10K ohm potentiometer, and it's connected to P1, P2, and P3 terminals. This is our run forward switch right now. It's connected to S1 and S2. To run in reverse, we will move S1 to S3 so that S2 and S3 are connected. We'll do that in a little bit. Right now we're going to run forward. Alright. There we're powered up. There's a green LED on, and then there's a red LED on. And the green LED indicates that power is applied to the drive. The red LED means that the drive is stopped. When I enable the drive to run, that red LED will go off. Look at that. And here's our waveform. We'll get close to the oscilloscope so that you can see the phase control that that DC drive is providing. Now if we had a DC motor connected to this drive, it would be rotating right now. Let's get close to that oscilloscope. The oscilloscope set to 100 volts per division. Let's enable the drive to run. We'll increase the amplitude with the speed potentiometer. Look at that. That is a nice waveform. The bulbs are pretty bright right now. We'll lower the amplitude. It's a good run and drive. Okay, I'm going to stop the output and I'm going to move our switch set to run forward right now to run reverse. Let me turn the drive off. Okay, I'm moving my enable switch, my run forward switch, to run reverse. Now it is connected to S2 and S3. I'm going to move that trigger point down so that we can trigger on the waveform that's going to be reversed now. I've just applied 220 single phase to L1 and L2. Let's enable the drive to run reverse. That trigger just a little bit there, we're locked in. Now you can see that the waveform is moving in the negative direction. And so that our motor would run counterclockwise now. You can slow down with the speed potentiometer, and we can speed up with the speed potentiometer. Isn't that amazing? That's a good running drive. That is a good running drive. Now let's remove the variac. And we'll run the drive directly from the wall, and we'll run a DC motor on this drive instead of the light bulbs. Hot. Light bulbs are hot. You don't need no gym membership around here. Well, I'm always moving motors around and everything. All right. Let's get our wires in down here. Go ahead and hook up our oscilloscope to A1 and A2 so we can see what it looks like with an actual motor connected to the drive. It's going to look different. It will look different. Come on, get on her. That might do it. Alright, there's one. Let's try the other one. I had to put my close-up glasses on. Okay, let's do the same thing. There we go. You have to get the probe and the wire under the same side of the screw. Okay, now for the line voltage. We're unplugged from the wall. Let me cap off that one leg that we're not using. There's L1. There's L2. L3 is capped off. We're not using it. Let's plug ourselves into the wall. Just make sure the drive is disabled. We're still in reverse here. Alright, we're powered up good. We have a green and red LED. Get my glasses on over here. And we're moving. Swap my armature wires around. The drive's set up to run reverse, but the motor's running clockwise. So let me swap those wires around so we get oriented correctly. Let's get unplugged from the wall so we don't get ourselves shocked. Plug ourselves back into the wall. Good. Now let's see which way we go when we apply the reverse switch. Now we're going right. close to the oscilloscope and we'll see what the waveform looks like with an actual DC motor connected to A1 and A2. I've got the oscilloscope set to 50 volts per division. Now watch what happens when I increase the voltage. Now here is ground. We're moving counterclockwise. Here's the SCRs firing. And you can see that the DC moves closer to ground the slower we run. Now there's 50 volts applied to that DC motor, 50 volts. Okay. Right there's min speed. That's the minimum speed that drive will run. There's a potentiometer here for min speed and max speed. Okay, I've just stopped the drive. Now we're going to run forward and see what the waveform looks like. Okay, I've just moved that switch from S3 to S1. Now we're set up to run forward. Let me move that trigger point up. There we go. Now we can see that our SCRs are firing on the positive side. There's 50 volts positive applied to the DC motor, and we're running clockwise. Here's the SCRs firing right here. I don't want to go too fast. That's a 90 volt armature motor. I don't want to burn up our motor. That'd be terrible. Well, there you go, folks. Hope you enjoyed running that KB drive right there. That was a real nice drive to hook up and run. I'll put some drawings of my hookups there, and that way you can test your drive. Have a good day, folks. Have a good day. We'll see you next time. Evening all. Got all my chores done. Got the laundry done. The birds have been fed and watered. Tommy the shop cat, he's got a full belly. Garden out back's been watered. So what are we gonna do now? Let's talk about this DC motor speed control manufactured by KB Electronics. This is model KBCC-225R. Now its input, according to the data plate on the drive connected to L1 and L2, is 220 volts AC single phase. You want to be careful. KB Electronics makes 110 volt versions of their DC drives. You don't want to put 220 volts AC on a 110 volt AC drive. You might not be able to fix it afterwards. Speaking of that, I just had a board in the shop, a control board, where 24 volts DC was applied to the 5 volt DC logic. It did not survive. Oh hell. Wouldn't have been so bad, but the microcontroller got wiped out along with the rest of the TTL logic. I could not repair that one. So here we are, L1 and L2, 220 volts AC, single phase. Now you'll notice in the video that when I first fired up this drive, I used a variac. I gradually increased that voltage up to 220 with a variac. The reason I did that is because when the drive came into the shop, it was missing the horsepower resistor and the fuse for the armature. There's a fuse here that goes to A1. It was missing. Now I checked the diodes and the SCRs that make the field and run the motor, and they were not shorted, but I didn't want to have an accident if there was an accident there to have. So I applied 220 volts AC with the variac to L1 and L2. Another reason for doing that is because at first I had a light bulb load out here. I had 2 light bulbs, and those 2 light bulbs simulated a DC motor. Now, with the variac and the light bulbs, you're not going to have a whole lot of current draw out here. But when we applied the DC motor to A1 and A2, I wanted to come off the wall. So at that point we came from the power plant into L1 and L2 with 220 volts AC, single phase. The potentiometer, a 5 kilo ohm potentiometer connected to P1, P2, and P3, allows for speed control. You can slow up, you can slow the DC motor down or speed it up with that 5 kilo ohm potentiometer connected to these 3 terminals right here. Now to run forward, I only had 1 switch, but in this picture right here, I show a normally open, normally closed, normally open, normally closed switch, but I didn't have that. I don't have a switch like that. So what I did was I connected the common to S2, and I had the switch contact connected to S1 to run forward. And then when I wanted to run the other direction, I removed the switch from S1 and moved it to S3 so I could run that DC motor counterclockwise. So S1 we moved clockwise, S3 we moved counterclockwise. Now you notice in the video that I had to swap A1 and A2 to reverse the direction of that DC motor. When we first ran and I closed S1 to S2, the motor ran counterclockwise, which is backwards. So I swapped the armature wires, and then when I closed S1 to S2, the motor ran clockwise. And then moving the switch from S1 to S3, maintaining common on S2, and closing that switch, that motor ran counterclockwise. Just be careful, and remember that there's some of these KB electronic drives out there that are 110 volts AC. And you'll have no trouble. You'll have no trouble. Now what was wrong with this KB electronic drive? It came in without the horsepower resistor. There's a horsepower resistor on there. I'll show you a picture of it. And it was missing the armature fuse. So my guess is that the customer, when they put this up on the wall, it didn't work. And so they sent it to us to try to figure out why. Well, it's not going to work if you can't power up your motor because you're missing a fuse. it's not going to work because you're missing the horsepower resistor. I'll show you pictures of that. And it's also in the KB Electronics manual for this drive that you can find on the internet. Alright all. I hope you enjoyed that video. I like running these little drives like this. They're real easy to hook up. Not hard at all. Now I've probably forgotten a chore that after I turn the camera off I'm gonna have to go do. Okay, here we go. Come on, more chores. It never ends, does it? It never ends. Have a good day, all. Have a good day with your families and enjoy your time on this side of the dirt.